Now, why do we have multiple tables? Hopefully, you can see that by breaking up what at first seemed like single entries of data into multiple rows in different tables and linking them together through primary and foreign keys, we've captured a proper relationship between various elements of our data. This is data analysis, and it must be done on anything we wish to store in a database. It's the only way to properly capture the schema of our data. And newsflash, sometimes our initial data analysis will be wrong, and we won't realize it until after we're underway and using it in production. That's okay. It's possible that you started with a system that only had one author per book, but later on you realized it needs to be a many-to-many relationship. Multiple tables with the right relationships between them also solves a different problem, making updates efficiently. Let's imagine the book table look like this: an ID column and a title column. 1, Dune. 2, Dune Messiah. And let's imagine the author table has an ID and a name column. 6, Frank Herbert. And the book author table contains an ID, a book foreign key, and an author foreign key. And it contains 116 and 226. Now, do you notice anything wrong in our data set? Perhaps a typo in Frank Herbert's name? It's easy to fix. Simply issue the following update statement. Update author, set name equal to Frank Herbert, or name equals Frank Herbert. That's pretty straightforward. In fact, this is incredibly efficient because that copy of the author's name is only stored in one place. What if we'd never migrated the author's name into a separate author table and instead kept it in the book table? If we had ID, title, and author, we'd have 1, Dune, Frank Herbert, and 2, Dune Messiah, Frank Herbert. Now the typo is in two places. How do you get the typo out of there? Well, surely you've seen applications where the user enters one piece of data that's then copied elsewhere, making mistakes like this. Of course, we can write an equivalent update. Update book, set author name equal to Frank Herbert, where name equal Frank Herbert. But it's important to understand that the database engine is now having to fix 2 rows of data. While not a deal breaker in and of itself, this potential for data duplication, if multiplied across the entire schema, would introduce potential data consistency issues that may quickly become unmanageable. Instead, it's better to properly model the relationships between the various bits of data and build relationships between tables that prevent such data inconsistency. With a separate book and author table and a well-defined many-to-many relationship between them through the book author table, it would be much harder to enter an incorrect author name. And even if a bad entry were made, it wouldn't be hard to fix the data while maintaining data consistency. In addition to the cost of making updates, it's also the pure fact that storing an author name twice, or over 100 times for prolific writers like Isaac Asimov, eats up disk space. While disk space shouldn't be a primary driver for decisions, it is a factor. Redundant data takes up space and requires additional maintenance to ensure data integrity. The right structure with a proper relationship between tables reduces duplicate data and makes data maintenance as efficient as possible. Up to this point, we've talked mostly about how to store data and represent various relationships, but we haven't touched the good stuff, querying for data. Querying is the whole reason we're doing this. What good's a database loaded with data if you never fetch any of it? And having discovered a keen reason to spread our information across multiple tables, we're going to need to join our data to get it back.